Hello and welcome back. In the last video, we created this standard cell template. And in this video, we are going to use it to lay out an inverter. So what we can do is go to the library manager and open up our inverter. And then launch layout GXL. And they'll pull up side by side here. Then what we want to do is we want to generate all from source. And this will pop up. What we would like to do is change these to Metal 1 drawing. Change this one also to Metal 1 drawing. These are global. Our PR boundary height is 6, as we discussed in the last video. And utilization, it doesn't really matter. We'll just say 60%. Otherwise, all is well. Check off accept global pins, and you don't actually even have to change these. Click OK. And we will get our transistors and our 2 pins. Next thing we want to do is create an instance from the library inverter, the cell template. You can see it right here. We then want to place that right anywhere. Hit escape so that you're not placing multiple, and we can delete this PR boundary or move it out of the way for now. We can then move this template to where it should actually go, which is right on the origin there. And then this PR boundary, we can move it back so that it falls right there, and then expand it so that it is the same size. Beautiful. Now, because we have this template, it is going to be very easy to lay this out. Let's start by moving our PMOS into its position. We'll move it as close to the power rail as we can get it without it yelling at us for DRC errors. Is it going to get mad? Seems like it's okay with this. We're also going to move it as close to the side as it'll allow us to. Good. And then what we want to do is we want to take this NMOS and do the same thing. It's always nice if we can get the Y's to be just perfectly aligned. Makes it easy for us. But it's never that easy. And then we are going to connect all of our nets. So this is our metal 1. It's going into ground. This is our VDD. Connects to VDD. And then our Y will connect to our other Y. And then we're going to connect our poly to one another. Keep it very thin, and then just so that it's minimum size. Then we can connect this one with some overlap. Beautiful. Next thing we're going to want to do is turn on our routing grid. Now, when you're doing standard cells, every pin should be on the routing grid. Like every pin should be on the routing grid. It's not a debate. If you place your pins on an intersect like this, then they can be routed to from the top and the bottom. If you place them just on a line, then they can only be routed to from two directions. So what we're going to do is we're going to place this Y pin right on this intersect here. And that should do. And then we are going to place this A pin right on this intersect here. And that should do. Now, we actually aren't able to get them right on the intersects. So what we have to do is we have to go to Editor and maybe not Editor, I think it might be Display, Options, Display, yeah. And change this to 0.05 and this one too, 0.05. Click OK. And now we can. Good. Perfect. Next thing we're going to need to do is create a via from our poly to our metal 1. That's right there. And this can be anywhere. And then what we want to do is connect these two polys. And connect these. And all is well. And then also connect these. Beautiful. Wonderful. And that is laying out our inverter. Very simple task. In the next video, we're going to go over how to verify these results using DRC LVS and then extract our parasitics. Thank you.